Hi everyone. I'm going to be doing a introduction to derivatives and to calculus in general. And so let's get started. First, I wanted to talk about this notation that we use in calculus. Basically, you're going to see this a lot. This just means that you're taking the derivative of a function f at x with respect to x. So when you see that, just know that you're taking the derivative of a function with respect to x. Similarly, this is a shorter form of doing it, and you'll also see this a lot. It is called f prime. All right, so let's get started. Let's say I had a function, and inside that function you had two terms adding or subtracting each other. In this case, we have x squared plus or minus 3x. So if I wanted to take the derivative of this function, say d over dx of this function, I would actually be able to do them separately and take their derivative separately, and then just add or subtract their derivatives from each other. So basically, I would be able to do the derivative of x squared, and then the derivative of 3x. I'd be able to add or subtract their derivatives after that. We're not going to do the derivatives right now since this is just an introduction to addition and subtraction. I'll be doing it later in this video. So let's move on to the constants. When you do a derivative of any constant number, in this case it's a number 7, the derivative of any constant is 0. So that's important to keep in mind. Any constant that you come across in calculus, the derivative of it will always be 0. In this case, we have a constant multiple of 3 in front of the x squared variable. So when dealing with this, you can actually move this constant in the front and keep it here. So that actually makes things easier, as now we can ignore this 3 and just do the derivative of the x squared. So basically it would come out to 3 multiplied by the derivative of x squared. Now, this might seem a little confusing, but later on in the video when we start learning about the power rule and how basically the power rule with derivatives works, this will make a lot more sense. And lastly, doing the derivative of the exponential function e to the x, this yields e to the x. So the derivative of e to the x is just e to the x, and that's very important because this function comes up a lot in calculus. All right, the last thing I wanted to do in the introduction is sinusoidal derivatives. This is something that you're going to have to remember. Unless you do a full proof, then you won't be able to solve it. So basically, you need to just remember the derivatives. So the derivative of sine x is cos x. The derivative of cos x, is negative sine x. And lastly, the derivative of tan x is secant squared x. So, like I said, you're just gonna have to remember this, and over time, over practice, you'll get it more. So, now I'm gonna start talking about the power rule, and the power rule is probably one of the most important rules you're gonna need to know in calculus. The power rule says that if you have a function f at x, and this function is composed of a variable x raised to a power of n, where n is any number, then the derivative of this function f at x is going to be n multiplied by x to the power of n minus 1. So I think the best way to do this is to just begin with an example. So let's say I have a function f at x is equal to x squared. And this is just a very simple power rule use. So I want to find the derivative f prime at x of this function. So first, I'm going to do it on the side right here. We have we have the term x squared, and we want to find the derivative of that. So we're going to just plug it into this formula. In this case, n is equal to 2. So then we get 2 as n right there. Multiply that by x to the power of n minus 1, so 2 minus 1. Now we just simplify that. We get 2x to the power of 1, or just 2x. And that is your derivative of that function. Now let's move on to another example. Let's say we have a function f of x is equal to 3x cubed. All right, so if you remember the constant multiple rule, we could actually move the 3 in front. So what we're going to do here is we're going to bring the 3 outside, and we're going to go d over dx of this function x cubed. We're just going to keep the 3 on the outside, and we're going to do the power rule for this x cubed. So we're going to take down the n, and the n in this case is 3. And then we're going to do x to the power of n minus 1. So 3 minus 1 is 2. And then we can simplify this to 9x squared. Now we just plug this back in, and we get f prime at x is equal to 9x squared. All right, so now let's get into some examples that involve everything that was talked about in this video. The first example is f at x is the function f at x is equal to x squared plus 3x to the power of negative 3 minus 7. So first, I'm going to do the derivative of them separately, since there is addition and subtraction, which means I can do the derivatives of each of them separately and then just add their derivatives or subtract their derivatives. So if I wanted to find the derivative of the first term, let's do it on the side here. This is a simple use of the power rule. So first, the power rule says that we have to bring down the n to multiply by x to the power of n minus 1, and n minus 1 is 2 minus 1 in this case. We get 2x to the power of 1. Let's put that in, 2x. Now we move on to the second term, 3x to the power of negative 3. Now we haven't used a negative, but it is the exact same way as the other power rules that we've used. So we have 3x to the power of negative 3. Now we have a constant here. We can just move that in front of the derivative. And we just do the derivative of x to the power of negative 3. So the power rule says that we bring down the n. That's the original 3 right here, multiplied by n, which is negative 3, multiplied by x to the power of n minus 1. So in this case, it's negative 3 minus 1. This gives me 3 times negative 3, which is negative 9, to the power of x, times x to the power of negative 4. So let's put that in. Negative 9x to the power of negative 4. Lastly, the third term, the 7 constant, negative 7 constant. So if you remember from the beginning of this video, taking a derivative of a constant will always lead to a 0. So this is just 0. So the derivative of this function is this. All right, let's do one more example. This example contains the exponential function and the trigonometric function. So let's do the derivative of this function. And let's do it the same way we did the other one, by parts. So for the first term, we're going to do the derivative of sine x. Now it's going to take some practice, like I said, but you're just going to have to get used to it and remember these trigonometric derivatives. So the derivative of sine x is cos x. Let's put that in, cos x. The next term is the exponential function. So doing the derivative with respect to x of e to the x gives you e to the x. If you remember from the beginning, the derivative of an exponential function, e to the x, is e to the x. So let's put that in. And lastly, the term x. Now, this can be a little bit misunderstood. This is actually the power rule is being used here. That is because although it's just a singular x, there is a power 1 to this x. So we're just going to do the power rule with the power 1. And the power rule says we bring down the n, multiply that by x to the power of n minus 1, in this case 1 minus 1. Now we know that 1 times x is just x, so we have x, and 1 minus 1 is 0. And from simple algebra, we know that anything raised to the power of 0 is 1. So we're going to put that in there, and we have a plus 1 for the derivative of x. And this is your derivative for this function. I hope you liked the video, and I hope you learned a lot. Thanks for watching.